Hello, everyone. My name is Carlo Giacometti. I am the manager of the Sound and Vision team. And today I will be talking about how to connect to REST APIs, even though I will not be limited to REST, but that's a small detail. Okay, the service framework. It's just the name that we give it internally. It's the suite of functions that are around Service Connect and Service Objects. It was introduced a bunch of years ago, more than 10, as a way to interact with API services. So often companies provide APIs, also provide client libraries or SDKs to interact with API in other languages. With Wolfram language, that usually doesn't happen. So with the service framework, we're trying to provide that same level of experience. So the user doesn't have to build an HTTP request from scratch and analyze the response. They just can, use some, in our case, Wolfram language function that smell and feel like any other Wolfram language function without having to comb through details of APIs. And this has become more and more important now with LLMs. Effectively, the most practical way to use LLMs is to send requests to some computation providers, and OpenAI is obviously one of the main ones in that domain. So these were kind of the motivation, what this is and why I got started. Why do we want to do it? Well, all of these functions, as I said, were introduced more than 10 years ago. They have lots of quirks, especially regarding credential handling and lifetime management of these credentials and the connections. The maintenance of these older connections was very, very obscure. There was no documentation. Service submit had a very poor implementation of asynchronous requests. Service submit is a way to perform an async request. The equivalent that you can think of is URL read and URL submit. One performs the request, waits for the result. The other one performs the request, spits out the task object, and then handles responses that come using handler functions. Service submit previously was just doing a very silly thing. It was just doing session submit of service execute. So we had to go to great lengths to make this work with Notebook Assistant and Chatbook. It was very painful. Loading times were terrible. Code was problematic to find. So we wanted to clean up house, kind of provide the same functionality that existed, just a bit more polished experience and clearer documentation for both internal and external developers. So we have, as I said, the previously documented system symbols, service star. There is now a collection of service framework symbols that will help internal developers and potentially external developers to develop and manage connections. And as you can see, there's a large amount of them. I published some of the internal documentations for this. This is probably something most of you will not be particularly interested in, but they are now in a public cloud notebook that you should be able to access. So before starting, I will quickly go through a few terms that it's good if everyone agrees on. So a service connection is the definition of how we connect to a specific provider. For example, Archive, OpenAI. So it is effectively a big association that holds all the information on how to perform these operations. A register service connection is a service connection that the service framework is aware of and it has been loaded. A service object is how the user uses a service connection. It is identified by the service name, which is the same name as the service connection, service ID, And then this, I think we can kind of ignore for now. This is associated to a specific set of user credentials. The credentials that belong to this could be none, could be a string, could be an association, could be a secure authentication key. The user can pass it through either inputting in a dialog or using the authentication option. A raw request is an HTTP request that maps exactly to an API endpoint. The only processing that we do in this case is verify that the parameters match what the API dictates. So not very much. A processed request instead can be an arbitrary function that has very well-defined parameter verification and normalization and result post-processing. So I will first look at how the end user can use a service connection, and then we'll touch on how to build a new service connection. I'll try to go through this reasonably quickly because this is functionality that has existed in the system for a while, and the changes that are user exposed are fairly minor. $services tells you everything that the service framework, well, almost everything the service framework is aware of. Then we can connect. In case of archive, there is no authentication required. For OpenAI, a dialog pops up that I guess I am not sure you can see, unfortunately. Well, a dialog pops up. It asks you for an API key that you can input. And Dropbox requires instead in opening a web page to verify the OAuth connection. If you don't want dialogues, you can specifically pass an authentication option. And there is a save connection option that tells the system if these credentials need to be stored and where they need to be stored and for how long they need to be stored. So if there are already existing credentials or service objects for a specific service name, the default service object for that connection will be retrieved. And by the way, an interesting thing that is new, you can, or partially new, you can get information about the service object itself and the connection through some values. So you can look at what properties are, what requests exist. And then this is a new addition for each of the requests. It will tell you what parameters exist and what are the accepted values for those. This is all automatically generated. I will ignore this bonus section about details. An interesting part, though, is how credentials are stored. So I'm going to delete all of my existing connections. By the way, delete object works on service objects, which is great. I don't know what went wrong there, but we'll ignore that too. In this case, I am specifying authentication as a delayed value. And you can see this has not been evaluated. This echo has not produced anything. Once I execute a request, at that point, that authentication is evaluated. So if you wanted to withhold your credential, for example, storing them in system credential, you could specify a delayed value for authentication. This is a feature that wasn't present before. By default, the connection is not saved for multiple sessions. It just exists within a single session. So if you quit the kernel, that disappears. It could be saved to your system credentials. And this is managed by the service framework itself. You don't need to interact at all with this at all, in any case. Or the credential can be saved to a secure cloud object. So then you have access to your credentials for that service connection across multiple machines, as long as you're logged in the same cloud object. To perform synchronous requests, this works very much like you might have already seen. There is nothing new here on the top level. Just do service execute, what service, what request, and then what parameters. We are trying to encourage people to send parameters as associations so that they don't get confused with options and there is no silliness going there. Service execute has a very limited set of options. They are pretty self-explanatory. If you pass an explicit authentication to service execute, this will not be stirred. This will only be used for the request that you're calling for in service execute. Here I'm building the exact same service request, and embarrassingly, I use the list of rules rather than association. Don't do that. It will work anyways, but I think things are much clearer when associations are used. And here I am submitting the request, and I'm specifying handler functions and handler function keys to figure out how to get back my information. And you can see the task exists, is slowly executed. Once I look at the result is appended to that. And again, this now finally works properly asynchronously rather than it's just a synchronous request performed in a different kernel. So I talked about credentials. I was talking about delete objects and service objects. Service objects, by the way, is a new function that allows you to figure out what connections exist in your current session. And these, have names, and they could be either user assigned or automatically assigned, and they all store credentials with them. As I briefly mentioned before, delete object now works on service objects. So if you want to completely remove a credential that you have stored, for example, in this service object, this will take care of it. Again, I'm not entirely sure what that warning message is. And you can see now I don't have any more existing connections. Service objects can take an argument that is a string that will give you all of the service object for that specific connection. And delete object can delete one object, multiple objects, can delete a list of them, etc., etc. I will not dwell on this too much. So, how do we define a new service connection to an arbitrary service that provides a REST API? Well, the main tool that we have is the internal define service connection function. I have again here, this links to the same internal documentation that you should be able to access. I will share this notebook after this presentation. Define service connection takes an association, basic parameters. This is not very interesting. The name, I'm telling this that there is no authentication required. This is yes, of course, I will share the notebook. This is the base URL to which the requests are made, and I'm telling the service framework that any request that I will be specifying will be allowed. So in this case, if I look at services, now my test connection should have appeared right here, and I can connect to it. Nothing, no pop-up happens because there is no authentication. And if I perform an objects request, the service framework is inferring that I should just append this string to that base URL. And it performs the request. And you can see I don't get binary data or something silly like that. It knows from the response what format the data is in and imports it appropriately. In this case, I think it was a JSON packet, and it got imported as a list of association. The way to, so this is the basic way, right? In a kernel session, you build your association and run the find service connection. But what if you wanted something a bit more permanent that could be discovered by the service framework at startup? Well, that is what packlets are for in general. You could build a packlet that has inside it a call equivalent to this that will evaluate once the packlet is being loaded. And the service framework will know to load that packlet if you add to the extension list a service connection extension. So you could have any arbitrary number of other extensions and then a service connection, and you'll need to specify what is the name of that connection and which context the service framework should try to load to activate this connection name service connection. For example, web search, and you can have multiple service connections defined in a single packlet. For example, web search defines a Bing search web service connection and a Google custom search service connection. And this is, as I said, you can arbitrarily define as many as you want in a single packlet or a multiple packlet. So authentication is usually the most complicated part of all this. And there are several fields in that association that I briefly showed before that allow you to kind of automatically have the service framework handle that. As you can see, authentication schema, method, parser, function, dialog, verification function. There is a whole variety of things. Authentication schema tries to kind of incorporate all of the other parameters in one. So if you define an authentication schema that is, for example, has a type API key and goes into the query, all of these other fields will be constructed for you automatically. If you want to do something more hands-on, you can define these separately. And the methods that are supported are no authentication, API key, which could be one single string, multiple string in association, username, password is kind of a catch-all category, and then auth, which could be both auth 1 and auth 2. There's a question about LLM doing all the boilerplate here. Well, we've tried some of that. It wasn't particularly successful. This is why the framework tries to do the boilerplate for you rather than the LLM. Some of it, especially because I'm sure the LLM would be able to do this kind of boilerplate coding in languages such as Python. But in Wolfram language, I don't think they have a high hope of being successful, especially for dealing with anything that is related to auth. Again, there are several ways to customize this here, but I think there are several default cases where the boilerplate code will be spared from you. Especially if you manage to use one of the supported authentication schemas. So after you've defined one way or another the authentication details for your specific connection, you want to define the requests. In general, you want these to map directly to the requests in the API. I feel like this transformation would be easily solved by the LLM. However, another thing that is important to know is a lot of these providers give you an OpenAPI specification, and you can programmatically mine that to build this automatically as well. So while you could use an LLM, I'm not sure the uncertainty of result makes it worth it over programmatic definitions. For requests, again, a set of parameters. They are documented in the main internal documentation that was linked at the beginning of this notebook. I have a bunch of parameters, some go in the query, some go in the body, some go in the headers. And I know that I want to get the response, and it will be automatically imported. I define this request and redefine my test connection 2 again. So that now exists. You can inspect it. And you can do this for existing connections as well. So this could easily be OpenAI, for example, or whatever existing connection in the language. You can perform the request, and I'm echoing that. That looks correct. Obviously, it doesn't produce anything because it goes to a non-existent API. But you can see it handles the failure appropriately. You can specify all these parameters, and if you want to inspect where those parameters go, you can see that this has been constructed appropriately with parameters in the header, in the query, and in the body as a JSON string. Path parameters also exist, so rather than having stuff, for example, in the query, they can go in the path as well. In that case, you will want to use a string template to define the URL for that specific request. And there's an example here. Par1 should now go there, and you can see that the URL of the request, in fact, uses the value of that parameter. As I said before, the convention that we've had internally is that the raw requests mimic the API endpoints quite closely. I will give you a real-world example. So I am defining an OpenAI connection that is completely new, has nothing to do with what we have in the system. I call it OAI. I'm just using an API key authentication method, and I know that this will need to go in the headers parameters. And I will define an embedding raw request that hits the embedding endpoint. It's a post request, has this set of parameters, and these are the required one without which the service will not work. And as you can see, it just does that automatically, performs. This is the actual key that I use. The result is imported appropriately and is a real Wolfram language object rather than a HTTP response. The second layer above the raw request is the processed request. And the idea is that this is kind of a Wolframized wrapper of raw requests. The idea is that every process request will be effectively performing a raw request internally, but it will pre-process the parameters going into it and post-process the result in a way that kind of fits with the rest of the system. But there is no such limitation. The process request is an arbitrary function, but we do provide shortcuts for that specific eventuality where we want the core of it to be a raw request. So the flow for that process request is first check the parameter names that are specified in the definition, verify the parameter values, and the developer should specify something to validate those parameters. For example, I know that for my request, for par name parameter, I will only accept a string or small or medium. Then the parameters need to be somehow normalized. For example, say if the API only accepts strings, well, we can say that in this specific request for this specific parameter, I will provide a set of replacement rules. So small will be transformed into the string 150, medium the string 250, etc., etc. And then the parameters names are mapped to the names of the parameters in the raw request itself. You also have an opportunity to process all the parameters together. So if there are if there is some parameter 1 that depends on some parameter 2, this is the place to do it. And then a request is executed, and the response is post-processed. So let's take a connection. This has a single raw request. I define it. This is great. This doesn't return anything because this is a garbage value that the API doesn't know about. Here, I will add to it a processed request. I know that I want ID to be a positive number, but I know if it is a real number, I will transform it to the rounded version of itself. So in this case, if I'm passing an invalid parameter, the service framework will tell me that this parameter is not supported. If I pass it a wrong value but the correct name, I will be informed that the value for this is incorrect. And if I pass 5.1 like I did before, my processed request that I defined will know that this will need to be rounded, and it outputs the correct result. And we can define a different code path for service submit. In this case, it will be the same. The system framework will know to handle this differently in the two cases. And if I look at this, I have effectively performed a URL submit operation, and I've received one body chunk with information and one that was just an empty string. The execute function can be more complex, obviously. This is an example of that. And as you can see, I am echoing stuff, I am evaluating things. So it is not limited to just map to a raw request. It can be an arbitrary function to perform any kind of operation you desire. And with that, I think we're just in time to conclude the talk, and I will upload this notebook, and hopefully will be attached to somehow the information about this talk. If you have any questions, feel free to ask them now. By the way, one additional note is I briefly mentioned the OpenAPI specification. I think that is a very interesting direction for development, and I would like eventually for a user to be able to define a full service connection by just doing define service connection of an OpenAPI JSON file. And we've in fact have done that partially for example, the 11 Labs service connection. Automatically generate all of the raw requests. So hopefully the development time for external services will be completely minimized. I feel like the combination of this kind of programmatic approach and LLM generation will be a very powerful one. Thanks again. Have a good day.